Hi, my name is Norman and today we got something exciting. Well, we got a new type of manufacturing. It says here under the sticker, yeah, it's a SainSmart CNC machine. So in there we got instructions, side panels, cables and other cables. You guys know I love boxes, so that's pretty cool. All the parts sorted. More cables. Oh, these are probably the drill bits, or how's it called? Cable sleeves. This is the gantry. So the whole X-axis is actually already assembled. Plastic covers. Mainboard. Yeah. The spindle, controller, screwdriver. And now comes the Y-axis. Whoa, okay. So, and here it is. Everything unboxed. Now we are going to assemble this bad boy here. So I think we should get the parts we don't need right now out of the way. Well, I don't know why they include that screwdriver, because I assume that actually everyone who starts with CNC manufacturing at least should have a set of screwdrivers at home. So we're going to start with the instructions. Of course we are. Free giveaway, and also activate your warranty. So thank you card, scan the QR code in the back, joins, yeah, don't care. This is the good stuff, right? Welcome, disclaimer, unboxing, mechanical installation. We're gonna start at page 8. On the instructions they are wearing gloves, but I'm just gonna risk the pinch hazard here. Zip tie, go away. Now, okay, I get it. So step 1 is, well, screwing down nuts. So we are going to screw down the build plate, or whatever it's called, to the motor driver. How does it work? Okay, these screws here should align according to the instructions, but they don't. These things here, they should be able to push around, but these are solid. But looking at those here, they aren't. So I'm going to loosen all the screws on the other pieces here and push the entire thing a little bit up so that these holes here are going to align. M6 16mm. I think that's those. M6 16, yeah. And now we're just going to align everything again. I'm gonna wiggle a little bit so that they move into the right position. Yeah, these things in the middle are not moving, but I'm looking here now. That thing isn't centered. So I don't know. There's probably a trick to move them, because it seems like there's some kind of spring down below. But I think I'm just going to settle down with not moving that thing, so it's not centered. Yeah, maybe one day I'm going to fix that. For now, I'm just going to go with it. So for the next step, locate the limit switch mount indents on the inner side of the frame, one on each side as shown below. Limit switch indents there, in there. Okay. Now we're going to install cable holders. 6 cable holders here, and these are going on the outside actually. I'm not sure about these pictures here, but I think one goes on the inside here, right next to those indents, and the other one goes on the outside, on both of them. So we're going to do that. Use that cheap screwdriver here. Okay, I just did that wrong. I could have just read the instructions. It says 2 on each side and 2 on that side of the motor, on the outside. 2 here, 2 there, and then 2 on the back outside. Maybe once in a while it's good to read the instructions, right? And well, to my surprise, the English in that instruction book is actually pretty good. Yeah, usually you get like this Google Translate English. Yeah, this here is Seems right they spend at least $5 to pay a translator to translate that. For now, on page 9, it feels like. Okay, next page. Install one limit switch on each side by tightening the 3mm screws. So 1, 2, 3, 4, and 2 limit switches. So they have this detent here. Give me a little bit more space here. Next step. What you will need: 4 rubber feet, Allen key, 3mm, Y-axis base assembly. Step 1, locate the pre-drilled holes and install the rubber feet on each corner using the Allen key. As simple as that. 4 tiny cute little rubber feet here. And the 3mm Allen key. Pre-drilled holes, great. Next step, what you will need: 2 limit switches here, cable holder, 3 of those, 1, 2, 3, 2 ABS spacers, 1, 2, 6 of those M3 screws, and 2 of M320. I suppose these are those. Yeah, I'm gonna change that. We're gonna read because we learned that, right? The first limit switch to install is on the stepper motor side. You will need the 2 wide ABS spacers and the longer 20mm M3 screws for this step. Locate the 2 pre-drilled holes on the inside of the gantry next to the lead screws as shown in the picture below. Using 2 and 320mm screws to secure the limit switch, followed by the spacers into the frame. Okay. That. Okay, now on the outside, it's that way. On that side, we're going to use these 2 holes here to install cable holders. I think it's really great that they included all the cable management. It's gonna be very secure because you're not going to end up with your cables in front of your spindle, hopefully. And now on the other end, yeah, there also goes a limit switch. That one goes directly into the frame without any spacers. I also like that they have limit switches on both ends. Well, that makes sense because these things don't really work like 3D printers. Because a 3D printer, you have your slicer and then it's gonna constrain, like you just said, slicer max settings 20 centimeters, and then it's gonna home on 0, and then it knows that it's not allowed to travel past 20 centimeters. On these CNC routers, you just home your 0 on some random places, basically. Yeah, the machine will never know where exactly within its constraint it's moving, or it is, basically. That's the reason you need limit switches on both ends, so that you don't damage your machines. It's more likely to happen accidentally here, that you hit somewhere where you don't want to hit. Again, why base assembly? Gantry alignment tool. That way. They start with this side, but probably you're going to do that on both sides. Place the long end of the gantry alignment tool towards the back of the base frame with the motor into a channel and align 2 of the nuts, 1 into each slot. Then slide the 3rd nut up to the touch of the short edge of the tool. Pretty cool that they include that. With this little plastic thing here, it's going to help you to position the whole gantry assembly. So for some reason they want you to start on that side, so motor back of the machine to your right hand side. So we're gonna take the long end. I'm just going to, okay, that's harder to move them than I thought. They want us to move long end here. Pretty nice, actually. Cool. Repeat for the other side. Why do they want me to start on that specific side if it actually doesn't really matter? But okay. Wow, multi-purpose. For the next step, we're also going to use that tool here. Beautiful. That little gantry alignment tool is also a spacer for the bottom. So now you put it sideways, and then you have the perfect spacing, I suppose. No, you don't. Oh, right, because you're not putting it sideways. That way. So I'm not going to tighten them because I'm going to repeat that on the other side. And then I'm going to tighten down these screws. Just feels more like how you're supposed to do it, right? I don't know how it says in the instructions because I don't know, I'm really bad at following instructions. Well, the instructions for me are more or less like guidelines, and sometimes I mess it up, but that's the price I pay. I just feel like I'm enjoying these builds more if I get to think a little bit. So now we can start tightening the screws. Okay, have a look. This is how it looks at the moment. So I'm really happy. I'm really looking forward to using that thing. Next step is install the spindle. The ER11 collet. Here, this collet comes in a little box. Pretty cute. Or that way. So this is an ER11 collet. I'm completely new to CNC milling, so I don't know if I just broke it or what ER11 stands for. Probably gotta remove that. Ew. These things are interchangeable. You can replace it with a larger one so that you can insert larger tools. What way does it go in? Let me see. Great. There's just a blurry picture of that. Well, it only goes in one way, so yeah. It's locked in place by pushing it, then oh, it's supposed to lock. Is it? Okay. I have no idea, so I'm just gonna leave it that way for now. Loosen the spindle mount hex screw. There's an LED here on top, I think. It looks like something which is going to light up. So I prefer having that in the front for some reason. So yeah, I don't know. I'm just gonna do it. Dude, that's... Here, very important, tighten the hex screw to secure the spindle, but do not over tighten the screw as it can damage the mount. Yeah, probably for that I would have used 2 because you can already see it's bending. So I'm gonna leave it as is. Yeah, 2 screws would probably have been better so that you don't get that banana here. But seriously, this thing is entirely plastic. Maybe one day I can just disassemble it and reprint that in better. It's gonna be very fun, this thing. I'm already looking forward. So now, acrylic baffles. So these are the side panels here. These things here have a print on the outside, so I suppose this one is supposed to go here because the print on the inside would be kind of stupid. So let's see how easily they peel off. I have very bad experience with that. Yeah, I once had the first generation Anycubic i3, and that was very tedious work to peel off these acrylic sheets. So this is a bliss that it works. I remembered it just tearing apart. Even with large parts, the paper here just tore, and that was so much work. Like, I would have just taken half the time to assemble the printer if that wasn't that tedious here. So yeah, huge step for paper protective things in acrylic sheets, because now it's easy to peel off, sort of. Also, pro tip, you can keep these and use them as baking paper later. No, please don't. So, 8 of these T-nuts. Insert these T-nuts. Come on. So now we take the clear piece first, and then we are going to well, again, I could have just followed the instructions, because you're gonna have a whole lot easier time if you just put them in here first. You can do that for the other side as well. Easy peasy lemon squeezy, right? Now to the other side. Congratulations, now your machine frame is fully assembled. Let's move on to wiring. Okay, we're gonna move to the back of the machine. This is where we are going to, attach that thing. So there's a protective plastic layer on top. You can see that it's matte. Yeah, we're gonna remove that because I think the clear acrylic will look a lot nicer. And that way also we can, have a nicer look at the board really quickly. This is the main board, really nice heatsink, matching colors, that's great. USB-B cable, I think that's the power input, 24 volts DC, and all the other connectors. Horrible sound, but beautiful view. Okay, we gotta repeat the same steps for the back side, unfortunately. Peel off. Okay, now the same thing as with the side panels here. T-nut and, screws. And then we can put it anywhere here inside these axis assembly. Pre-drilled holes, blah blah blah. Position the frame in the back of the machine so that it's facing you. Install the board by inserting, okay, it doesn't really matter at which place you put that. I'm going to follow the instructions and put it somewhere closer to that side. So the side where the motor is for the X-axis. Oops. I cracked it. Very easy to crack. That's a bummer. But because this thing is not very load bearing, it doesn't really matter. Side of the board horizontally, leave out 30mm space between the board and the left edge. Why does it say here 30mm? Thank you very much. We're gonna make it 30, right? Now I can tighten all those blah 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 screws. Did that already, great. You will need limit switch cable X-lim plus and X-lim minus 15 and 53 centimeters. That's pretty neat. All these cables here are labeled. We will need X-lim plus and X-lim minus. Plus and minus here. Great. Here are the slots for the limit switches and, the shorter one for the X limit switch on 0, more or less, is here. So that's weird that X0 is here. On a 3D printer, 0 is here, and now X0 is here. Yeah, we're gonna see that later, how it's actually going to work. Run the cable behind the control board along the top channel of the bottom beam, then loop around the control board. Boop. There you go. Run the cable, blah, blah, blah. Okay, did that. Press the sealing strip flat side out over the cable top channel. Okay, we're already done with that one, that's great. So these plastic parts are called sealing strip. Gonna slide it here along. Nice. Because, well, that's not only cable management, but also the strip here will prevent dirt from being collected inside that beam. So now we need the Y limit switches, plus and minus. So now we need to flip that over and put the cable here. Yeah. And then we're also going to use one of these covers to store the cable safely. Genius. So I assume that they want us these cables to have, yeah, I think they are supposed to go underneath the machine. Well, on the instructions, there's an image where it's going to run the direct way. Doesn't make sense to route them here on the inside because the machine is going to get dangerously close to that. I'm going to run them around here if there's enough cable actually. Never mind, we have to run it on the inside because, yeah, there's not enough cable left. Yeah, they have a video about cable management, but I don't feel like watching a video right now. So now the limit switch is for the Z-axis. So the plus switch here goes on top. And the minus switch goes on the bottom. As simple as that. Connect the other end to the main control board. Okay. Gonna do that. Okay, and now we are going to put in the motor drivers. No, the cables for the motors. This one is the shortest, probably X-axis, yeah. Y-axis. Gonna cheat and put on the spindle. Plus is red. And then we're gonna put in the Z-axis. The E-stop is the next thing. Okay, lubricate, check cable routing, emergency stop button, VREF, currently going to stepper motors. Okay, before we start with the final checks, I think we should we? Yeah, we should do cable management. Okay, and here it is. Have a look at those cables here. So we got all the cables nice and managed, and some of you might be like, wait a minute. Where does that drag chain come from? The drag chain wasn't included, I just had it lying around. I really didn't like how the cables were dangling around before. That's why I designed and 3D printed this little plastic piece here. Yeah, of course I couldn't help myself. I started modifying this machine before it even runs. So yeah. So all the screws are with threaded brass inserts. First time for me using them in a real build. I think I can never go back to using hex nuts. I'm just going to use threaded brass inserts forever now. And here in the back I also printed a little bracket because, well, I used one of the spare T-nuts to tighten the belt to the gantry. I can just snap it on and it's going to support the drag chain. So here in the back, I think the cables won't get much more managed than that, and to be honest, I'm still not quite happy. Maybe we are going to print a box to house everything, include a cooling fan for the heat sinks here, all that, I don't know. For now it's gonna do. We will power up this puppy, right? I'm just gonna let that dangle here in the air. So the version I got at least comes with an offline controller. So usually with CNC routers you plug them into your computer and then you control them from your computer. But this one has an offline controller, so that way I can control it without a computer. And I can even insert an SD card and actually also, you know, run G-code directly from that thing here. This is probably the way I am going to run it because, well, it works more or less like a 3D printer. But it's alive, more or less. The Y-axis still has some weird resonating thing ongoing. Maybe I need to tighten some screws, I don't know. It's also great to hear that it has some sort of silent stepper drivers. The stepper motors are very, very quiet compared to unsilent stepper motor. So, want to see some action? I'm gonna press home. It's slow, right? So that's great. Now we know that you know, all the limit switch work, which is a relief because I actually had to do some soldering here to get this drag chain working because of course all the cables weren't long enough. The version I got also comes with a probe. This is the thing which you use to you know, measure your Z distance. So you put that on your workpiece. And that thing you put on your spindle, on your end mill, and then once it touches that piece, it knows exactly where it is in Z space at least. Yeah, I haven't figured out yet how to use it. It's not included in this in the instructions. I'm gonna do that one day later. And for the last finishing touches, we are going to install these little things here. I printed them also in PETG, by the way, that blue color. I found them online, so this is not my design. These things are going to go right into these extrusion profiles to prevent the dirt to get caught in there. So, okay, I forgot one. Okay, we're done, right? So all the edges here are nice and clean, closed up. To be honest, that design here is really great. It's easy to print and it just fits perfectly into, well, these 2x2, 20x20 extrusion aluminum profiles. Really great, props to the designer here. Gonna link it down below in the description. Also this drag chain bracket, I will upload it on Thingiverse so that you can also download it if you want to, as well as that bracket here, all for download for free. So I think we can call it a day now. I'm going to fiddle around with the machine a little bit, try to get it run and update you in another video how it's been doing. I'm pretty positive it will be a lot of fun. I hope you had a lot of fun watching me building this thing. And that being said, thanks for watching and see you guys in the next one. Bye bye.